start refraction, plane refraction of light. Refraction. Light. What is this thing? Actually, you observe that what is happening when the light is traveling from one medium to another medium, like this one. Light is traveling. This is a medium 1. I'm just going to drop a perpendicular, and it is coming to the medium 2. Just like the medium 2. From medium 1 to medium 2, light is traveling. So now, if I am going to drop a normal at the point of incidence, so what you can know, this is angle of incident, angle of refraction, all of you know. All of you know. So the property is that whenever the light is traveling from one medium to another medium, the light gets change its path. You can see the light would have traveled in this direction, but now it is bended, isn't it? So it is going in this direction now. So this is angle of incidence and this is angle of refraction. What is the angle of incidence is that? Well, if I just drop a normal at the point of incident and the light ray is dropping, with the normal, what the angle it is created, that is the angle of incident. And this normal, with it is created another ray. And so this angle is angle of refraction. Okay. So now from the generalized Snell's law, there is a law is there existing that sine I divided by sine R, it is called a constant. It is called Snell's law. It is called a refractive index of the two with respect to 1. It is a constant and it is called Snell's law. Refractive index of the medium 2 with respect to medium 1. So now what we can observe from here, if we want to just define this thing, what is this thing? Refractive index of the medium 2 with respect to the medium 1. If I see that, so why the light, if I just want to analyze the process, that why the light is going to bend, actually speaking, whenever the light is going to change the medium, the speed of the light is going to change. Suppose the speed here v1 and the speed here v2. Why it is going to happen? Because wavelength gets changed. If the light is going to change the medium, wavelength changing. So now I can write it like this way: v1 is equal to n lambda 1, v2 is equal to n lambda 2. Isn't it? N means frequency into wavelength, wave speed, frequency into wavelength, wave speed. So now you can see that we can tell that we can define refractive index of the medium 2 with respect to medium 1. How we are going to write this? Medium 2, refractive index of the medium 2 with respect to medium 1, we write like this way, just like v1 by v2. That we write this ratio. v1 divided by v2, this is a ratio, isn't it? Then we can write like this way, like you can see the n lambda 1 divided by n lambda 2. So this n cancelling out, refractive index of the medium 2 with respect to 1 is equal to v1 by v2. That should be lambda 1 divided by lambda 2. Just we can write like this way. So similarly, it can be put at this thing can be put at here, sine I by sine R. That normal expression, sine I by sine R is equal to mu 2 1 is equal to v1 by v2 is equal to lambda 1 by lambda 2. Check. Very good. Now children, see, whenever light traveling from one medium to another medium, light traveling from one medium to another medium, we have to observe what kind of the quality these two mediums are going to exist. First of all, we have to understand that optical density, normal density, a medium is a denser medium. How can I define? Mass by volume, that is the density, mass density. But it is not that mass density, it is not that mass by volume. No, it is optical density. It's a special thing. You have to understand that thing. So how can I tell which medium is optically denser medium? we have to know that if I want to find the refractive index of a medium with respect to vacuum or air, more specified vacuum, তাহলে কি বলছি refractive index of a medium with respect to vacuum, then that refractive index is the important factor, that is called absolute refractive index. So how I can tell absolute refractive index is, what is that thing? A refractive index of a medium whenever I take with respect to vacuum, that is called absolute refractive index of that medium. যেমন আমি বললাম, suppose I'm just going to have a giving an example. I'm going to take refractive index of the water with respect to vacuum, then that is called absolute refractive index of water. ঠিক এটাকে নেব কিভাবে? So how to take this thing? I'm taking the medium 2, mu2. I'm just going to not writing here. Nothing I'm writing. মানে এটা কি? এটা absolute refractive. It is absolute refractive index. It just we are going to write like this way. It is a rule, just like try to remember. C divided by V2. C is what? It is the speed of the light in the vacuum. It is the speed of light in the vacuum divided by V2 is the velocity of the light. It is the velocity of the light in the medium 2. This is called absolute refractive index. So if I'm going to think that what is the absolute refractive index in the medium 1, so we can write like this way: mu1 is equal to C divided by V1. Simple. ঠিক আছে, তাহলে তুমি দেখো C I can write like this way: C is equal to mu2 V2 is equal to mu1 V1. That's the process I can write, isn't it? Isn't it? So now you can see, children, like this one, mu2 divided by mu1 is equal to V1 divided by V2 na? So mu2 by mu1, V1 by V2, এটা লিখতে পারি? Can I write? Definitely we can write. So ultimately we can write like this way. Instead of V1 by V2, here I have just taken V1 by V2. I'm just going to write like this way: mu2 divided by mu1. ঠিক আছে, so now mu2 by mu1 is equal to sin I by sin R is equal to mu21 is equal to V1 by V2 is equal to lambda 1 by lambda 2. This is the normal expression. This is the normal theory. You have to remember this thing. ঠিক আছে না ঠিক নেই? Understanding, children? Understanding? Everyone understanding? I think you understand. If you're not getting this, if your confusion is arising, you just connect with a Vidyanist. No problem. We are going to help you out. Okay. But this thing you have to remember this. Simple thing. So mu2 by mu1 is equal to refractive index of the 2 with respect to 1 is equal to sin I by sin R is equal to V1 by V2 is equal to lambda 1 by lambda 2. Now see, we were discussing about the absolute refractive index and about the optical density. Now think just what the thing is that a medium which is having a higher absolute refractive index, just like if I just going to take an example, mu2 is more than mu1. If I'm going to think that the mu2 greater than mu1, then I'm going to tell that refractive index, absolute refractive index 2 is more than 1. So 2, this medium 2 is optically denser than 1. Simple কথা. It is optical denser. Medium 2 is optically denser than 1. Can? Why? Because absolute refractive index is more. It is not just concerned, there is no connection between the mass density that you have to remember. That's, I think the children, it is clear. Everybody clear? ঠিক না? বুঝতে পারছো? So therefore, I'm just going to reduce the shape little bit. ছোট করে দিলাম, ঠিক আছে? Now একটু বড় করি। Now see what the thing I'm going to get. Mu2 by mu1 is equal to sin I by sin R. So mu2 by mu1 is equal to sin I divided by sin R. Just cross multiply. Mu2 sin R is equal to mu1 sin I. ঠিক আছে? Mu2 sin R is equal to mu1 sin I. Just observe. Absolute refractive index here is equal to mu1. Absolute refractive index here is equal to mu2. What the angle is existing in this one medium 1 I na, that I. তাহলে এখানকার রিফ্র্যাক্টিভ ইন্ডেক্স, দ্য অ্যাবসলিউট রিফ্র্যাক্টিভ ইন্ডেক্স এক্সিস্টিং হিয়ার mu1 multiplied by sin I, the angle existing, ঠিক, আর অ্যাবসলিউট রিফ্র্যাক্টিভ ইন্ডেক্স এক্সিস্টিং হিয়ার mu2 into sin R. This multiplication mu into the angle in that medium, sine of that angle in that medium, this product is a constant. That is called generalized Snell's law. This is a normal Snell's law and this is called generalized Snell's law. বুঝতে পারছো? Everyone understanding, children? I think you understand. Yeah? Very good. So simply just we can think that mu into sine I, আমি বলতে পারি just like mu1 sine I1 is equal to mu2 sine I2 is equal to mu3 sine I3 dot dot dot. So this process continues. This is going to continue. So mu1 sine I1, mu2 sine I2, mu3 sine I2. This is the continuation. The process is going on. This is called generalized Snell's law. This is the trick. We can use this one in a lot of problems. We can use. We can use in a lot of problems. Okay. Very good. Now see, children. I'm going to change this page. Okay. Let us just apply some in the some applications in some how can I just use this process mu into sine mu1 sine I1 is equal to mu2 sine I2. This theory, this method, how can I use some applications? Let us see. Now see, this I'm going to have a container. I'm going to have a container which is having a height 3h. Okay, very good. And you can see just like I'm going to split into 3 parts. This is h, this part is h, part is h. Total 3h, isn't it? Now see, if I'm just going to place some something a rod like of structure here in this portion, a rod like of structure h, a rod, metal rod existing in the bottom, which is having a height h, just like this way it is existing, and from this position we just can observe the top point of the rod like just straight, because straight line, the light is coming from this point, the top point of the rod, the red colored rod from here traveling. Okay, now what the question is telling, that question is telling that just if I'm just going to pour some liquid, I'm going to place liquid মানে ধরে নাও water, suppose I'm just going to fill up to this this 2h length, this is 2h, I'm filled water up to 2h length. So what the thing is going to happen here, we can see that the bottom point of the rod is visible through this point. So how, just like see, from the bottom point the light ray is going to travel like this way, and it is going to bend like this way, going to bend. Now see, you can just simply think, as previously we have discussed, light coming, light, it is I, this is R, suppose this is I1, this is I2, this is mu1, this is mu2. Okay, according to generalized Snell's law, what we can observe from here, mu1 sine I1 is equal to mu2 sine I2, already we have just discussed. So let us think that the mu2 is bigger, mu2 bigger than mu1. So this medium, suppose this medium 1, this is the medium 2. Medium 2 is optically denser medium. This medium 2 optically denser medium. So mu2 greater than mu1. Naturally, sine I will be greater than sine I2. Therefore, sine I1 greater than sine I2. If this condition satisfied, so it should be followed. Sine I1 greater than sine I2, isn't it? So therefore, we can just conclude that I1 greater than I2. Understanding my point, children? Understanding my point? So therefore, I1 greater than I2. Money, you can observe that the I1 is bigger than I2. Money, the light would have traveled in this direction if the medium 2 was not present. But now it has bended, it has turned in which direction? Nearer to the normal, towards the normal. That's why the I2 is lesser than I1. Mane, when the light traveling from a rarer to denser medium, what happens? Light bends towards the normal. The mathematically the thing is going to come. And if the reverse thing is going to possible, if from the medium 2, the light is traveling to the medium 1, from a denser to rarer, it will bend away from the normal. Simple thing. So similarly, you can observe from here also. You can see, if I just going to see that I drop a normal this way. If I'm going to take this is 2h, mane this width of the container, but actually speaking, the diameter of the container is 2h. So what the thing is going to happen here? You can observe, children. This is h. This length is h. So naturally, the remaining portion is 2h. This is h. This remaining portion is 2h, and this is 2h. Yeah. So this 2h and this 2h. I've dropped a perpendicular from here. This is a 90 degree. Naturally, if this is 2h, this is 2h. So this is 45 degree. Huh? You understand? Simple geometry. This is 45 degree. We can observe from here. Okay, very good. Now see what the thing is going to happen. If this is 45 degree, naturally, this is also 45 degree. This is also 45 degree. No problem. If this is 45 degree, you can see this is 2h, this is 2h. So this part is h. Because the total 3h, this part is h. Naturally, this is 45, this is 45. So this is also h. Understanding? It's a simple geometry understanding. Now, so this is also h. So 2h. So this point is actually middle point. Actually 2h, it is going to become middle point at this position. Okay. So now whatever thing is going to happen. So now we want to get the angle of incidence here. If this is the theta. This is the theta. Okay. So now from this situation, if I want to get the refractive index of this liquid, of this water, I want to find the refractive index of the liquid. Suppose I'm just going to have mu. They have told just some liquid, the water type of liquid, just they have poured, and we want to find the refractive index of the water or whatever the liquid is existing here. So what the process we are going to follow here? This is a theta, angle of incidence, and now what is the refraction, angle of refraction? Just simple geometry, simple trick. This is the 45 degree, isn't it? You're understanding my point? Huh? You're understanding my point? Now see, how can I find the theta? You can see this is my 2h, this is my h, because already we found this is h, so naturally this is h. Total length is 2h, so this is h, and this is 2h. So therefore, the tan theta can be found is equal to h divided by 2h. Therefore, the tan theta I can write half h by 2h. Therefore, tan square theta mane 1 by 4 mane bolo sec square theta plus 1. Sec square theta plus 1 is equal to 1 by sorry, sec square theta minus 1, because tan square theta is equal to sec square theta minus 1, sec square theta minus 1. So sec square theta is equal to 1 plus 1 by 4 mane 5 by 4, 5 by 4. Therefore, the cos theta, just we can conclude that 2 by root 5, isn't it? I mean, cos square theta kota bolte pari? Cos square theta, I can write 4 divided by 5. So if I just make a square root, 2 by root 5, isn't it? So we found that cos theta. Therefore, 1 minus sine square theta is equal to 4 by 5. Therefore, we can tell that sine square theta 1 minus 1 by 4 মানে কত হয় তাহলে sin square theta 1 minus 4 by 5 5 minus 4 মানে 1 by 5 is equal to sin square theta. Therefore just we can write sin theta is equal to 1 by root 5, isn't it? ঠিক কি না? Sin theta is equal to 1 by root 5, which is found from this geometry. Simple trick, just you just observe this values and you have to put properly. Okay, so now for the solving, just if I want to get the refractive index, so if I just going to have the refractive index mu into sin theta, just it has gone to the air, the ray has gone to the air, so now the 1 refractive index 1 into koto sin 45 degree sin 45 degree. Okay, so angle of incidence, the angle of refraction, this is I'm just going to have simple generalized Snell's law, that formula we are going to use. So mu into sin theta, what the value of the sin theta? 1 by root 5. 1 by root 5 is equal to sin 45 mane 1 by root 2, isn't it? Check. Therefore we can write like this way, root over 5 by 2. This is the refractive index of the liquid, just whatever we have put it here. According to that, this geometry is coming, this refraction is going to